The 2002 National Electrical Code does not contain a specific code requirement for grounding electrical metallic tubing, abbreviated EMT, sleeves in garages. It's important to recognize that the 2002 NEC is outdated and should not be used for new electrical installations. The 2005 NEC requires that EMT sleeves in unfinished basements must be grounded. This specific requirement is explicitly for unfinished basements and does not extend to garages. Therefore, based on both the 2002 and 2005 NEC, there is no mandatory code stipulation to ground EMT sleeves used in garages. Despite the absence of a mandatory code requirement in the 2002 and 2005 NEC for grounding EMT sleeves in garages, it is widely considered a sound and recommended practice to ground all metal raceways and enclosures, which includes EMT sleeves. This approach enhances electrical safety and minimizes the risk of electrical shock or fire hazards. Grounding metal raceways and enclosures provides a path for fault current to flow back to the source, enabling overcurrent protection devices, such as circuit breakers or fuses, to quickly trip and interrupt the circuit in the event of a fault. This helps to prevent dangerous voltage build-up on the metal parts, which could pose a hazard to individuals who might come into contact with them. There are several effective methods for grounding EMT sleeves. One common technique involves using a grounding bushing. A grounding bushing is a specialized fitting designed to provide a secure and reliable connection between the metal raceway and the grounding conductor. It typically features a screw or lug that allows for easy attachment of the grounding conductor. The grounding bushing is installed on the end of the EMT sleeve, and the grounding conductor is connected to it, establishing a continuous grounding path. Another method for grounding EMT sleeves is to bond the sleeve directly to a grounding electrode. A grounding electrode is a conductive rod, plate, or other object that is buried in the earth and connected to the electrical system to provide a low impedance path to ground. Bonding the EMT sleeve to a grounding electrode involves using a bonding jumper, which is a conductor that connects the sleeve to the grounding electrode. This creates a direct connection to ground, ensuring that any fault current can quickly and safely flow to earth. The size of the grounding conductor or bonding jumper used for grounding EMT sleeves must comply with the requirements of the NEC. The NEC specifies the minimum size of grounding conductors based on the size of the overcurrent protection device protecting the circuit. It is crucial to consult the appropriate tables in the NEC to determine the correct size of grounding conductor or bonding jumper for the specific application. In addition to grounding the EMT sleeves themselves, it is also important to ensure that any metal enclosures or equipment connected to the EMT sleeves are properly grounded. This may involve using grounding bushings, bonding jumpers, or other grounding methods to establish a continuous grounding path throughout the electrical system. The NEC provides detailed requirements for grounding metal enclosures and equipment, and it is essential to follow these requirements to ensure electrical safety. When installing EMT sleeves in concrete, such as in poured top lintels in garages, it is important to take extra precautions to protect the EMT from corrosion. Concrete can be corrosive to metal, and prolonged exposure to concrete can cause the EMT to rust and deteriorate. To prevent corrosion, it is recommended to coat the EMT with a corrosion-resistant material such as paint or epoxy. It is also advisable to use a non-metallic sleeve or wrap around the EMT to create a barrier between the EMT and the concrete. The use of plastic bushings on the ends of the EMT sleeves is a good practice to protect the conductors from abrasion. Sharp edges on the EMT can damage the insulation of the conductors, leading to short circuits or ground faults. Plastic bushings provide a smooth, rounded surface that prevents damage to the conductors. However, it is important to note that plastic bushings do not provide a grounding path. Therefore, it is still necessary to ground the EMT sleeves using one of the methods described earlier. In summary, while the 2002 and 2005 NEC do not specifically require grounding EMT sleeves in garages, it is a recommended practice to ground all metal raceways and enclosures to enhance electrical safety. This can be achieved by using grounding bushings or by bonding the sleeve to a grounding electrode. The size of the grounding conductor or bonding jumper must comply with the NEC requirements. It is also important to protect EMT from corrosion when installed in concrete and to use plastic bushings to protect conductors from abrasion. Always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements and regulations. Electrical work should only be performed by qualified and licensed electricians to ensure safety and compliance with all applicable codes. Remember that electrical codes and regulations can vary depending on the jurisdiction. It is crucial to consult with local authorities and electrical inspectors to ensure that all electrical work is performed in accordance with the applicable codes and regulations. Ignoring or neglecting grounding requirements can have serious consequences, including electrical shock, fire hazards, and equipment damage. Grounding is an essential safety measure that protects people and property from the dangers of electricity. Therefore, it is always best to err on the side of caution and ensure that all electrical systems are properly grounded. In addition to the NEC, other standards and guidelines may provide further information and recommendations on grounding electrical systems. These standards may be published by organizations such as the Institute of Electrical and Electronics Engineers, abbreviated IEE, or the National Fire Protection Association, abbreviated NFPA. Consulting these standards can provide valuable insights and best practices for grounding electrical systems in various applications. When designing and installing electrical systems, it is important to consider the specific environmental conditions and operating requirements of the installation. Factors such as moisture, temperature, and corrosive substances can affect the performance and longevity of grounding systems. Selecting appropriate grounding materials and methods that are suitable for the specific environment is crucial for ensuring long-term reliability and safety. Regular inspection and maintenance of grounding systems are also essential for ensuring their continued effectiveness. Grounding connections can loosen or corrode over time, which can compromise the grounding path. Periodic inspection of grounding connections and conductors can help to identify and address any potential problems before they become a safety hazard. In addition to grounding, bonding is another important concept in electrical safety. Bonding involves connecting together all metal parts of an electrical system to create a common electrical potential. This helps to prevent voltage differences between metal parts, which can pose a shock hazard. Bonding is typically achieved by using bonding jumpers or other bonding devices to connect metal enclosures, equipment, and raceways. The NEC provides detailed requirements for bonding electrical systems, and it is important to follow these requirements to ensure electrical safety. Grounding and bonding are complementary concepts that work together to provide a safe and reliable electrical system. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metal parts are at the same electrical potential. By implementing both grounding and bonding measures, the risk of electrical shock and fire hazards can be significantly reduced. When working on electrical systems, it is essential to use appropriate personal protective equipment, abbreviated PPE, such as insulated gloves, safety glasses, and arc-rated clothing. Electrical work can be dangerous, and PPE can help to protect against electrical shock, burns, and other injuries. It is also important to follow safe work practices such as de-energizing circuits before working on them and using lockout/tagout procedures to prevent accidental energization. Electrical safety training is essential for all individuals who work on or around electrical systems. Training should cover topics such as grounding, bonding, PPE, safe work practices, and electrical codes and standards. Proper training can help to ensure that electrical work is performed safely and in compliance with all applicable regulations. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified and licensed electrician before performing any electrical work. Electrical codes and regulations are constantly evolving, so it is important to stay up to date on the latest requirements. The NEC is updated every 3 years, and local electrical codes may be updated more frequently. Staying informed about the latest codes and regulations can help to ensure that electrical work is performed safely and in compliance with all applicable requirements. The principles of grounding and bonding apply to a wide range of electrical systems, including residential, commercial, and industrial installations. Whether it's a simple residential wiring project or a complex industrial electrical system, proper grounding and bonding are essential for ensuring electrical safety. In addition to protecting against electrical shock and fire hazards, grounding and bonding can also help to improve the performance and reliability of electrical equipment. By providing a stable and reliable ground reference, grounding and bonding can reduce electrical noise and interference, which can improve the operation of sensitive electronic devices. Grounding and bonding are not just about meeting code requirements, they are about protecting people and property from the dangers of electricity. By understanding the principles of grounding and bonding and following safe work practices, electrical professionals can help to create a safer and more reliable electrical environment. Remember to always prioritize safety when working with electricity and to consult with qualified professionals when needed. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents. The goal is to ensure that all electrical systems are designed, installed, and maintained in a safe and reliable manner.